Hi there everyone, it's me, Teacher Annie. Welcome to your mathematics video tutorials. In this video, we're going to discuss about the introduction of set notation. For your learning objectives, at the end of this topic, the students will be able to first use set language and notation. Second, describe set. Third, represent set using roster method and set builder notation. So, what is set? It is defined as a set is a well-defined collection of objects. Each object in a set is called a member or an element of the set. The set and its element. We use capital letters or uppercase to name a set. For example, set A is the set of vowels of the English alphabet. So A here is a capital letter or an uppercase letter. So A is equal to A, E, I, O, and U. The elements can be letters, numbers, symbols, words, phrases, etc. The elements of a set are separated by a comma and closed with braces. For example, X is equal to, you have here your braces. So inside the braces is Sunday and Saturday. So in between Sunday and Saturday, you are having a comma. Next, Y is equal to P-U-E-T. So P-U-E-T is enclosed with braces and each letter is separated by a comma. Next, do not repeat the same element in any given set. For example, set M is the set of letters in the word baby. So in here, you have two letter B's. So it will be given as M is equal to A, B, and Y. You don't have to write B 2 times. Next, the elements. We use the following symbol to represent an element. So this is the symbol for element. How about for the next part? We use the following symbol to represent not an element. And this is the symbol. Next, go on for the examples. Let A is equal to A, E, I, O, U. So this one is actually the vowels of the English alphabet. Now, determine whether each item is an element of set A. Number 1, A is an element of A or is it not an element of A? So in here, the answer would be it is an element. Alright? Number 2, E enclosed with a brace is element or not an element of A. So the answer here would be not an element. Okay. Next, number 3. OU enclosed with braces is also not an element of your set A. Okay, so you have to remember that for the element, we will not enclose the letters with braces. So here, only number 1 is an element. The next example. Let A is equal to the letters in the word design. Okay, so the letters here would be letter D, letter E, letter S, letter I, letter G, and letter N. Now, determine whether each item is an element of set A. Okay. E is, of course, it is an element of A. Number 2, G is, of course, it is an element of A. And number 3, GN enclosed with braces, we will say not an element of A. So I hope this is clear. Next, set descriptions. Set description is usually a sentence describing a particular set. For example, number 1, A is the set of whole numbers that are factors of 6. So this one is a sentence. wherein our set is A. Number 2, B is the set of odd numbers less than 10. Number 3, C is the set of letters in the word options. 4, D is the set of roots of the quadratic equation quantity x minus 2 times quantity x minus 5 is equal to 0. And lastly, E is the set of all the first positive integers. The set of all the first positive integers. Okay, now in number 1, this is the set of whole numbers that are factors of 6. So letter A would be equal to, the factors of 6 are, what does it mean? Those are two numbers that when you multiply, it gives you 6. The product is 6. So that would be 1 and 6 and 2 and 3. Okay? So when you multiply 1 times 6 gives you 6. 2 times 3 gives you 6. Next, B is the set of odd numbers less than 10. So letter B would be odd numbers less than 10. So odd numbers, you have 1, 3, 5, 7, and 9. Less than 10. Next, C is equal to the letters in the words options. So you have letter O, letter P, letter T, letter I, letter N, and letter S. Okay, so here we have two letter O's, but you don't need to write it twice. You just write one letter O. Next, D is the set of roots of the quadratic equation. So that would be positive 2 and positive 5. And number 5, the set of all the first positive integers. So let's say first 3 positive integers. So that would be E is equal to, we have 1, 2, and 3. Okay? 0 is neither positive nor negative. So we'll start with 1. And then for the first 3 positive integers, that's 1, 2, and 3. Okay, moving on. Describing sets. So there are two common ways for defining a set. The first one is by roster method or listing the elements of the set. And the second by set builder notation. Okay, what is roster method? In roster method, all the elements of the set are listed. Okay, for example, A is the set of whole numbers that are factors of 6. So roster method, it would be A is equal to 1, 2, 3, and 6. So when you say factors, those are two numbers that when you multiply, it gives you a product of 6. Okay, this one is arranged from the smallest number to the biggest number. Okay, next example. Number 1, B is the set of prime numbers between 0 and 10. So how are we going to write that? So B now is equal to, okay, we're going to list the numbers. So prime number, okay, prime number, its factor is only 1 in itself. So we will begin with number 2. Okay, next, number 3, number 5, number 7. Okay, 9 is not a prime number. Okay, so that's the answer. Next, C is the set of letters in the word jacket. So we have here C is equal to letter J, letter A, letter C, letter K, letter E, and letter T. Okay, so this one, our answers are called the roster method. Okay, this is how we show roster method. We're going to list the elements. Next, letter D is the set of first 5 multiples of 4. What does multiple means? It means that it's a number when you multiply with 1, 2, 3, 4, 5, and so on. So multiples of 4 would be letter D is equal to, first 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. So we only need the first 5. So we have 1, 2, 3, 4, and 5. Okay, next, E is the set of months with less than 30 days. Okay, so letter E would be months. We have January to December. But we only need the month with less than 30. So of course, it's only one month. That is February. Okay, so that is our roster method. Next, moving on, set builder notation. In set builder notation, all elements are described by a common property that define them. Example, A is the set of whole numbers between 3 and 10. So set builder notation, it will be written like this. A is equal to X such that X is a whole number and 3 less than X less than 10. Alright, so between 3 and 10 is denoted as this one. 3 less than X less than 10. Okay, and then the whole numbers here would be this one. Whole numbers. Okay, what does this symbol mean? This symbol means such that. Okay, so the symbol is read as such that. Okay, in most cases, we can write A is equal to X such that X element of W and 3 less than X less than 10. Okay, W means whole. Okay, whole number, and X element of a whole number and 3 less than X less than 10. So this one can be written like this. Okay, so you can choose which of the two you're going to use. Right, next, more examples. Q is the set of letters in the word love. Okay, so you will write here Q is equal to X such that X is a letter, okay, in the word, okay, love. Okay, L-O-V-E. Okay, so X such that X is a letter in the word love. Okay, you can write it like this one. Next, R is the set of natural numbers. So have here R is equal to X, okay, such that X element of N, N being a natural number. Okay, next, S is the set of prime numbers less than 10. Okay, so S now is equal to, okay, X such that X element of, okay, prime would be denoted as P, and, okay, X is less than 20. So that's how you write it. So S is equal to X such that X element of P and X less than 20. Next, T is the set of multiples of 3 less than or equal to 20. So we will write T is equal to X such that X is a multiple of 3. X is a multiple of 3. And, okay, X is less than or equal to 20, and X is less than or equal to 20. So that's how you're going to write your set builder notation. Okay, moving on, number of elements. Okay, we can also count the number of elements. So the number of elements in set A is represented by n quantity A. So n here stands for number. Okay, stands for number. So you will not be confused. So n, what is n? It stands for number. So n of A means the number of elements in set A. Alright. The number of elements in any given set is called the cardinality of the set. Okay. Example, we have A is equal to A, E, I, O, U. So the cardinality of A is equal to 5. Why 5? Because we have 1, 2, 3, 4, and 5. 5 letters. Number 2, B is equal to 2, 3, 5, 7. So N of B is 4. So that is a given. So 1, 2, 3, and 4. Next, number 3. C is equal to Sunday and Saturday. So our N of C is equal to 2. And then for number 4, N of D is equal to PUET. We got 4. Alright? So that's simple. So what is the cardinality? It is the number of elements in a given set. Okay, letter E. Okay, so we have N of E is equal to X is an even number and it is between 3 and 10. So what numbers are those? So we have number 4, number 6, and number 8. Okay, that is our E. We cannot get 2 because 2 is already less than 3. Okay, so it's between 3 and 10, that is 4, 6, 8. So the answer is 3. Okay, so I hope this is clear. It's just cardinality, counting the number of elements in a given set. Next, finite and infinite sets. Okay, a set is finite if you can list all its elements. Otherwise, it is infinite. So if you cannot list all the elements, it means it is an infinite set. Example, for number 1, Z is equal to the set 0, 1, 2, 3, and 4. Okay, so here we already listed all the elements. So we have 1, 2, 3, 4, and 5. So it means this one is finite. Okay, it is a finite set. Number 2. So y is equal to 1, 3, 5, and so on until 15. So in this manner, you are going to stop until 15. So you can know the numbers. So that is also finite. Okay? So from number 1, 3, 5, and then what's the next number? 7. What's the next number? And so on. You stop at 15. So that is finite. Number 3. X is equal to 0, 2, 4, 6, and so on until forever. You cannot list all the elements. Why? Because you don't know where is the end point, where you are going to be finished or where you will stop. So this one is infinite. Next, number 4. W is equal to 0, 1, 2, 3, 4, and so on. Of course, this is also infinite. Okay, this one is easy. Okay, so just finite and infinite sets. Okay, next, moving on. Number 5, the set of whole numbers that are factors of 12. So when we say factors, those are numbers that when you multiply, it gives you a product of 12. So what are those numbers? So you have 1 times 12, you have 2 times 6, and you got 3 times 4. So how many are those? 1, 2, 3, 4, 5, and 6. Can we list them all? Yes. So it means this is finite. Next, moving on. Useful vocabularies. Okay, what are the useful vocabularies that we need for this topic? Okay, we have the set of numbers. The first part is N for natural numbers. Okay, natural numbers are also called counting numbers. Okay, counting numbers. Why? Because we start counting from 1. Okay, so natural numbers are also called counting numbers. Starts with 1, 2, 3, 4, 5, and so on. Next is the whole numbers. So whole numbers, okay, we will start with 0. Alright, next for integers, we have negative infinity to positive infinity. So we have here negative 3, negative 2, negative 1, 0, 1, and so on. Those are integers. If we have negative integers, you will denote this as z minus. Okay, if you are going to talk about positive integers, you have z plus. Okay, take note, everyone, 0 is neither negative nor positive. So it means it doesn't have any sign. Okay, it's just 0. It's not negative 0, it's not positive 0, it's just 0. Moving on. Q is equal to A over B such that A be element of Z means integers and B is not equal to 0. Those are rational numbers. So the examples here are 1/2, -3 over 5, -2 over 4, and so on. Okay, so those are rational numbers. So rational numbers are fractions and decimals. Okay, so these are fractions. Okay, and also decimals. Why? Because we can change our fractions to decimals as long as letter B is not equal to 0. It means you cannot divide any number by 0. Okay, next, irrational numbers are defined as any numbers that cannot be written as a ratio of two integers. Non-terminating decimals that do not repeat are irrational. So in here, for the rationals, not all decimals are rational numbers. Okay, non-terminating decimals are irrational. Okay, so what are the examples of irrational numbers? We have pi. Pi is an irrational number. Pi is equal to 3.14 and so on. You don't know when it will stop. Okay, and then we also have square root of 2. Okay, square root of 2, we don't know where to stop. Okay, so that is an irrational number. Okay, why? Because this one will give you an answer of a decimal number that is non-terminating. It means by non-terminating, it will continue forever. You don't know what is the final number. Okay, unlike when you have square root of 4, this one is simply equal to 2 or -2. So that's it. So you don't have a decimal here. So it means square root of 4 is a rational number. Next, moving on. Okay, even integers. So even integers, you also have -6, -4, -2, 0, 2, 4, 6, and so on. Okay, so if you have the positive even integers, you will denote as E positive, which starts with 0 and then 2, 4, and so on. Okay, so positive, we're going to take out 0. Why? Because E positive, it will start with 2, 4, and 6, and so on. Okay, we will not use 0. Why? Because 0 is neither negative nor positive. Okay, but in our cases, when you say even numbers, okay, when we say even numbers, okay, we will start with 0. Okay, 2, 4, 6, and so on. Okay, next, odd integers. So it's the same. Odd integers, what does this mean? When you divide a number by 2, the remainder is 1. So 3 divided by 2, it's 1, remainder 1. So that's odd integers. Okay, so you can review this set of numbers and then you can translate it into Thai in order for you to understand it more. Next is the prime numbers. So prime numbers are the numbers that has only 1 and itself as a factor. Okay, so in this prime number, number 2 is an even prime number. Okay, so it is the only even number that is prime. Correct? Because 2 is just 2 times 1 and nothing more. And then different set of numbers. All of these numbers, this family of numbers is actually called the real numbers. Okay? The set of real numbers denoted by R is defined as the set of all rational numbers combined with the set of all irrational numbers. Therefore, all the numbers defined so far are subsets of the set of real numbers. So in summary, we have the real numbers and then this one is the Venn diagram. This one is called Venn diagram. So the Venn diagram, we will study it more on the later parts of our topics. Okay? So far, you have different sets of numbers. So here, we have a summary. So O is the set of all odd numbers. E for even numbers, P for prime numbers, N for natural numbers, W for whole numbers, Z for integers, Q for rational numbers, and R for real numbers. So I hope you can remember this letter so that we can use it as our guide for naming sets for our practices and exercises later on.